All right, we're going to try and plastic gauge this first rod on the crank. We did open up the King .026 bearings for the rod, CR4125 XPG. This is actually XPGC, which is their coated bearings. They ended up sending me these by mistake instead of just the regular ones, so we're going to try and use these. Hopefully it'll be more power, baby. But it does say something on this little note that they would be a little discolored or whatever from corrosion, so we're going to wipe them off real good. Lots of stuff coming off these bearings. Okay, this one might be a good example. So on this package it says there might be, due to the thermal coating process of the P-Max coat, can reduce random yellowish red discoloration on the steel back. It says this is inconsequential and doesn't affect performance. I don't see anything that's yellowish red. Let's just see, like it just comes off. I guess this is this has to be like some type of something that they just coat the bearing in for shipping, right? That's got to be what this is. All right, I did do another little video of this torque process, but I didn't torque them to 43 foot-pounds. It was 43 Newton meters. So let's go over this one more time. We got a little piece of plastic gauge right there on the journal. So I know this isn't ideal, but this is what we're working with. Got the plastic gauge on, just going to slide the rod till it just barely meets the journal. I'm going to try and keep it rested on this. Hopefully this will be stable enough to not move the rod. It did move a little bit last time I tried it, so I'm going to put the cap on gently, try and keep everything together without moving. And we'll put in the ARP bolts. Got our 12.11 millimeter, and going to try and gently, see, I'm moving the rod already. Just slow and easy. Alright, so we are actually in foot-pounds. Before I was in Newton meters. For 38 was the OEM torque. For the Eagle website, it said for these 3/8 ARP 2000 bolts, it should be 43 foot-pounds with ARP Moly lube. They are oiled a little bit, not with ARP Moly lube, but you know, we're working with what we got. So 43 foot-pounds, and we'll torque both these down. There wasn't a whole lot of information in the little FSM thing that I had. It just kind of listed the torque, and that was about it. And a little description. When I go all the way to 43, I'm pretty sure I'm moving the rod all around. Alright, got them both to 43, 44 foot-pounds. I don't think the rod has moved that much. Alright, now we'll try and loosen this without moving the rod, which I'm pretty sure isn't going to happen.
I'm moving this rod all over the place. I haven't actually seen it move, it just... Let's see if it'll separate. No, it will not. Alright, a little dangerous here. Let's see if it'll separate now. I'll just left this in here. Ah! You see that? It moved all over the place. There's no way this is going to be an accurate measurement. Let's do that. I got the cap off the plastic gauge area. I know it's going to look like. I just can't trust that. I think the rod moved too much and I might have rolled the plastic gauge and spread it out. Let's check it anyway. 1.5 thousandths of an inch. So that would be a little bit on the tight side of the 1.5 thousandths. I did it earlier. Like I said, I didn't torque all the way down. Came out to 0.0017 instead of 0.0015. Only off, you know, 2/10 of a thousandths or 1 or 2 10,000ths. And then again, if we look up here at the spec in inches, our spec is 0.0007 to 0.0018 inches. So we're still well within that specification range on the top side. So I think we're good. I'm going to try and do the rest of these. They might roll, they might not. We'll see. We'll come back and I'll let you know how it went.
Alright, here we are. Got all the bearings plastic gauged for the rods. You can see here we've got the Eagle rods on the good crank. Eagle rods, good crank. We did torque to 43 foot-pounds. I was a little bit worried about the stretch of the bolts. I've heard a lot of people say that you need to measure how much stretch they have with a dial indicator. I did see some of that in the little FSM thing that I have, but I think that's mainly to ensure the integrity of the bolt and that it doesn't stretch too much or not enough. It does give an actual torque value specifically for the ARP bolts, which are different than OEM. So we just went with that. I think they should be good. I don't think these rods have more than like 1,000 miles on them. You can see here we did get, I'm gonna call these 1.7 thousandths, since everything is measured in thousandths. This is actually 17 10,000ths. But we did get pretty close to 1.5 thousandths or 1.7 thousandths. This was the first measurement that I took, and I don't believe I torqued it down to the 43 foot-pounds. I believe it was in Newton meters. I did the other three, number 2, 3, and 4, all came out almost exactly on the 1.5 thousandths mark. You can see here 1.5 thousandths, and then we'll look at the crank. The first two, I slid the rod in from the back and put the plastic gauge on the journal and then the cap on top of that. But in order to separate the rod from the cap, I had to leave the ARP bolt in there and then hit it with a dead blow hammer to separate it, and I didn't know if that was causing any deformation in the plastic gauge or inaccurate measurements. So I actually did that on the first two, and then on the second two I ended up putting the plastic gauge on the rod end and held it tight to the journal while I installed the cap. That way when I hit the bolt, it didn't affect the plastic gauge. So that's why these two are on this side, and then the other two are actually on the underside. That one's right there, and then that one we caught the oil hole. See right about there, it's extremely close to the 1.5 thousandths mark. So we're within spec at the top end of the specs. Top of the spec is 1.8 thousandths, so we've got a couple 10 thousandths room. I did hear that people run around 2 thousandths, which would be 0.002 for the rods. It is kind of unfortunate because if I had the standard bearings and coated or the 0.026 bearings and the non-coated, I could actually mix the two shelves and maybe get closer to the 2 thousandths target that I was looking for. I might even just put in the standard bearings in one of these rods and just check them and see how much looser it is. Maybe it's only a couple 10 thousandths looser, and we might go with standard size bearings on the rods. But let me check that out real quick and we'll see where we're at. Just a quick video of the plastic gauge on the rod side, or bearing side I should say. You can see these last ones, 3 and 4, is on the inside of the rod instead of the cap.
Alright, not sure what we can see here, but this is one of the King standard bearings, not coated, XPG Racing D82 standard. This is where you can see the yellowish red tint from the little notice we got on the coated bearing package, but that little notice is not on the regular bearings, just the installation instructions. Also looks a little color changey on the actual bearing surface. I'm not sure if that's normal or what, but I'm going to check it. You can see it still leaves a little bit of debris. I did clean them really well. Sprayed a bunch of brake cleaner and wiped them, but still getting some debris off of them. Okay, we're going to go with the Eagle logo facing us, tang to tang. It's the way I believe it's supposed to go, and then I am going to try and put the plastic gauge on the rod side. I did roll the crank over this plastic gauge, that's why I drew X's on it. So I'm just going to check it, and hopefully this one didn't get crushed by the crankshaft, this little piece I just cut off. And let's see if it looks flat or not. Yeah, it looks flat right there. I think all this is trash now. So, good thing I got a whole bunch of them. Let's try this again. Hit about that much. I'm going to put this up here to try and not destroy it. Let's get this little piece of plastic gauge. Probably going to make it to the final cut. We're just going to time lapse or something. Okay, so I got a little plastic gauge. Oil hole is directly opposite, so as long as we're not straight down, we should be good. I'm going to try and do this like this. Probably going to have to move that over there. Alright, slowly lower it down. Put it in place. I'm going to hold the rod like that. ARP bolt, tang to tang, numbers to numbers. Just trying to hold the rod flush to the journal. Now we're looking for 43 foot-pounds, 43 foot-pounds. Alright, 43 foot-pounds. Don't think I've moved the rod yet. I haven't spun it on the plastic gauge there. Let's see if we can loosen it. Okay, that's off. I'm going to do this interference fit with the locating pins is causing it not to separate. So what I'm trying to do is put pressure on the rod towards the back like that. Then once I hit it, it should pull away without any interference of the plastic gauge. And I can just take this off like this. And let's see. Oh, damn, hit the damn oil hole again. But these should be on the looser side. Let's see if we can get any type of guesstimation right on the oil hole. Yeah, it looks like it might be right at 20 thousandths. Maybe even a little thicker right there, meaning thicker plastic gauge than oil clearance.
We got it all plastic gauge with these standard bearings in, torqued them all, took them all apart. Let's look at the numbers real quick. This is what I estimated, about 1.9 thousandths on all of them, 1 through 4, which is almost to our 20 thousandths goal or target. And then real quick, we'll look at these just so we can see it for the internet. Maybe you can see the plastic gauge didn't, might have been a little oil on the crank or whatever, but you can get a little general idea of what it looks like. Maybe, maybe not. There's number 2. Number 2 might be a little different from the ends to the middle. Number 3, I think there might have been a little bit of oil on the crank. You can just barely see, like right there, where the imprint was, but number 3 on the rod is right there. And then number 4, right there. So from my understanding, the .026 bearings should be 1/1000th thinner oil clearance or less oil clearance. Right here, just from using the plastic gauge, it looks like it's a little bit less than 0.5 thousandths. I guess it just is what it is. I don't know if that's, you know, how it's supposed to be or if I got something else going on. The standard bearing is a lot closer to the target that I was looking for. The coated bearings, the inside, the actual bearing surface looks a little better. So I don't know, maybe somebody can let me know in the comments what they've used or what they've had success with or what they've heard about working good. Still undecided on if I should do the 026 bearings or the standard bearings for the rod bearings. I do have to gap the piston rings, the new piston rings, and I might see if I can check the balance on the rods and see if I can adjust it at all if it needs it. So I'll have a little bit of time to figure out which set I want to run. So just let me know and we'll keep moving.